Now coming to step 4. Step 4 is, so in the previous steps we have calculated HD of n coefficients, we have calculated Windows coefficients. The fourth step is computing filter coefficients. So it is HD of n. Okay, we have to calculate it. It is nothing but um, uh, the value we have calculated already. HD of n we have calculated. Sorry, we have to now calculate just a minute. So already given is HD of n is there, W of n is there. So what we have to calculate? H of n. H of n is nothing but HD of n into W of n. We need to multiply the corresponding coefficients. So H of 0 is HD of 0 into W of 0. Okay, so HD of 0 is 0.75 and W of 0 is 1. Okay, so we can have it as reference here. Okay, before we proceed, I'll just rewrite what is HD of n. Okay, so HD of n is given as 0.75 minus 0.225 minus 0.159 minus 0.075 0.045. Okay, and my W of n is given as 1.9045 0.655 0.345 and 0.0945 and 0. Okay, now given this we have to calculate H of n. Okay, so H of 0 is HD of 0. So I'll use a different color. Okay, so my H of 0 is equal to HD of 0 into W of 0, product of these two. Okay, so it becomes 1 into 0.75, it is 0.75. Similarly, H of 1 is product of these two. If you take the product of these two, it comes to minus 0.204. Surprisingly, this is equal to H of minus 1. We are not calculating this part, it will be the same. Similarly, H of 2 is equal to minus 0.104. This will be automatically equal to H of minus 2 because of the symmetric nature of FIR filters. Okay, similarly I can find out H of 3. H of 3 is equal to product of these two. It comes to minus 0.026. This is equal to H of minus 3, and H of 4 is equivalent to, so this one here it is 0, so it is 0, and H of 5, this is H of minus 4. Again here you have a 0, so it is again 0, that is equal to H of minus 5. Okay, now we have calculated the filter coefficients. Now once you have calculated the filter coefficients, we have to put these filter coefficients into the proper transfer function. So the transfer function of an FIR filter, is given as H of z equal to H of 0 plus summation n is equal to 1 to n minus 1 by 2 H of n z power n plus z power minus n whole into z power minus n minus 1 by 2. Okay, so it will come. So for our case, when n equal to 11, so I'll take this term first together, z power minus 5 into h of 0 plus summation n equal to 1 to 5 h of n, it is z power n plus z power minus n. Okay, so expanding it, z power minus 5 into, so we'll first expand it, h of 0 plus, if you substitute h of 1 z plus z inverse, okay, minus h of 2 z square plus z power minus 2 plus h of 3 z cube plus z power minus cube plus h of 4 z power 4 plus z power minus 4, and last we have h of 5 z power 5 plus z power minus 5. Okay, so from the previous step we know that h of 0 is equal to 0.75, h of 1 is equal to minus 0.204. okay, here h of 2 is equal to minus 0.104 and h of 3 is equal to minus 0.026, and h of 4 is 0 and h of 5 is 0. okay, so we can rewrite this equation as z power minus 5 into 0.75, that is my h of 0, minus 0.204 z plus z inverse minus 0.104 z square plus z power minus 2 minus 0.026 z cube plus z power minus 3. okay, now we need to expand this, so keep these equations safe. okay, we'll be using this equation later, so I'll put it as a, we'll use this equation again later. So this is nothing but my h of z, my h of z. So if you expand it and if you rearrange things, okay, so outside you have a z power minus 5. okay, so if you rearrange, it will come to minus 0.026. so highest power is z cube. okay, z cube, and z cube, z power minus 5 is z power minus 2. okay, z power minus 2 minus 0.104 z power minus 3 minus 0.204 z power minus 4 plus 0.75 z power minus 5 minus 0.204 z power minus 6 minus 0.104 z power minus 7 and minus 0.026 z power minus 8. okay, so this will be my h of z. okay, so we have calculated the FIR filter.